T star is to the left and beneath the plot with respect to where T naught is. Does that make sense? I know it's hard. I guess I need to just make a more dramatic example. That's supposed to be like the real data, but it's really hard to see what the hell's going on. Is that clear? So in other words, the steady state temperature is less than the feed temperature. Because when you start, you're removing more heat than you're generating, and so it gets colder. Does that make sense? Okay. All right, the last thing we're going to do is look at S versus the critical temperature. So first of all, the first part of the problem is looking at changing T naught. What's the effect on TS? That's ignition extinction. But I could also ask you a problem where you need to vary kappa in order to tell me again what is the kappa according to that tangential point, right? So I can have you fix T naught, and then you're varying kappa, which is the slope of this curve, in order to find where it's going to hit that tangential point. The third part is, if we look at this stability versus critical temperature plot that we made earlier, then what is my stable and unstable region? Stable. Okay, so to do that, you set a critical temperature, calculate T star, right? And then from that, you can calculate the rate constant, the conversion at that T star, and all of that gives you G at that T star, and S is equal to G at that T star times EA over R T star squared. And so this was in the problem statement, and this is again the T star that you get here. So it's not a simple solution. You set a value of TC, that gives you T star, you go on, you calculate G, finally you get to S, right? Rinse, repeat, and you get this curve. And again, when are we stable or unstable at this condition? And so just to have some numbers, all of these things are things I really can't ask you on a test, but what can I do on a test? I can ask you to explain some of these concepts if I show you these plots, right? But making these plots is not really something that you can do on a test. But we'll try to do it in homeworks. And then you can also calculate that at so these are just for two different points, what you end up getting for this CP naught times 1 plus kappa. You get two different values. And this lower one here is at this critical point. And so you're in a situation where if for some reason the heat capacity drops beneath this value, you're going to shift to the ignition temperature. Okay, so any questions? All right, so I think there's two problems in the homework that deal with ignition extinction. The last thing that we're going to talk about before the exam is multiple reactions with non-isothermal systems. And on the exam, you're going to get a multiple reaction problem, so just expect that. Because we didn't test you on it in the first exam either. So this is going to be the exam that has multiple reactions. Part of it will be isothermal, and then there will be a part with non-isothermal. Pick up the TA evaluation forms that are on that table near the door on the way out, if you didn't already grab one.
I just want to make sure my